Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a very interesting topic, which is called as validity analysis of Likert scale questionnaire. I repeat, the topic that I'll be discussing is validity analysis of Likert scale questionnaire. This video is very useful, especially for research scholars. Even before I proceed to talk about validity analysis and give you an example in SPSS on how to perform validity analysis for Likert scale questionnaire, may I request you to subscribe to my channel, also like and share my videos. Let me begin by asking a simple question. What exactly is validity analysis? If you are new in the field of research, this is one question which puzzles most of you. What is validity and how is it different from reliability? Many times, people tend to use these ideas interchangeably. In this video, I will clarify the difference between validity and reliability. The fundamental question is, what is validity and how do we evaluate validity of a questionnaire? The answer is as follows. Validity refers to how well a test, a tool, or measurement accurately measures what it is intended to measure. I repeat, validity refers to how well a test, tool, questionnaire, or measurement accurately measures what it is intended to measure. In other words, it is about the correctness or accuracy or truthfulness or the authenticity of the results. Here is a simple way to remember the idea of validity. If somebody uses the word accuracy of the questionnaire, authenticity or correctness, what should come to your mind is validity. They're actually asking you whether your questionnaire is valid or not. Now, to understand validity better, let me give you a very simple example. Imagine that you're using a thermometer to check if you have fever. If the thermometer shows you correct body temperature, it is valid. That is, the measurement instrument is valid. Validity ensures that the results of your test or measurement are correct and meaningful. There are different types of validity. Particularly, we have to keep in mind that there are three different types of validity. The first is content validity. The second is criteria validity. And the third is construct validity. Now, you may ask me, what is the difference between content validity, construct validity, and criteria validity? Let's begin with the idea of content validity. Content validity checks if the test covers all parts of what it is supposed to measure. I'll explain this in greater detail in a moment. Criteria validity compares the test results to another well-established measurement. And lastly, construct validity verifies that the test truly measures the concept it is intended to measure. Now, what is the importance of validity in research? Validity is crucial in research, education, and any field where accurate measurement is needed. Without validity, the results of a test or tool could be misleading, making it unreliable for decision making. A simple example would be, imagine you have a weighing machine If you step on it and it shows you correct weight, the scale is valid because it's measuring what it is supposed to measure, which is your weight. This is how you can understand the concept of validity. Many times, young researchers tend to mistake the concept of validity with another similar concept called as reliability. Now, I will clarify what is reliability. Reliability refers to the consistency of a measurement. I repeat, reliability refers to consistency of the measurement. The operative word being consistency. If a tool gives the same results under the same conditions repeatedly, it is reliable. Example, if you step on a weighing machine multiple times and it shows the same weight on each of these iterations, the scale is reliable because it consistently produces the same result. Many times people ask me, what is the difference between validity and reliability? You should ask a simple question when you talk about validity, and that is the scale showing you true weight? I repeat, is the scale showing you true weight? If yes, your questionnaire, or in this case, the weighing machine, is validity. It satisfies the validity criteria. Now, about reliability, you need to ask a simple question. Is the scale consistently showing the same weight every time you use it? The operative word, remember, is consistency. A very important point that people overlook is that a scale can be reliable but not valid. This is worth repeating. A scale can be reliable but not valid. Example, consistently a scale shows 5 kgs less than your actual weight. In this case, it is highly reliable but not a valid scale. For accurate results, both validity and reliability are important. I've made separate videos for reliability. I would request my audience to look at those videos in case you're interested in understanding the concept of validity. There are three types of validity, as I mentioned. The first one is content validity. This is a very important type of validity. Question is, what is content validity? In simple layman language, content validity ensures the test covers all aspects of the topic. I repeat, content validity covers all aspects of the topic. At first, this may be difficult. Let me break this down. Suppose you are giving a mathematics test. When you talk about mathematics, mathematics comprises of geometry, algebra, as well as arithmetic. A math test should include questions on all of these three areas, that is arithmetic, algebra, and geometry. If you were to exclude, let's say, questions related to geometry, you're violating the content validity criteria. This is why we are saying that a math test should include questions on all the relevant math topics, not just one area. How do you check content validity? This is a crucial point. You cannot use SPSS or Minitab or MATLAB or any other software to check content validity. Typically, it is assessed through expert judgment and is not directly measured in SPSS. SPSS does not have any option for content validity. I hope this point is clear to my audience. Let me now proceed to explain what is construct validity. Remember, construct measures a set of items. If you are curious to know what exactly is construct validity determines whether the test truly measures the theoretical construct it is intended to measure. If this is not clear, let me just explain with the help of an example. Let's take the example of a depression scale. A depression scale that correlates highly with other established measures of depression and not with unrelated constructs like intelligence. Now, this is what is called as construct validity. Now, if you ask me a simple question, how do we check for construct validity? The answer is very simple. You have to use a technique which is called as factor analysis to determine if the items load on the expected factors. So if you want to check for content validity, you have to look at expert judgment. If you have to look at construct validity, it is appropriate for you to use factor analysis to determine if the items load on the expected factors. I will be making a separate video for construct validity. Please give me some time. However, in today's video, I will be drawing your attention to the last of the types of validity, which is called as criteria validity. Criteria validity is very, very important, and I'd like to take some time to explain the concept of criteria validity. Criteria validity is a type of validity that measures how well one tool or test predicts an outcome based on another established measure or criteria. It shows how well the predictor aligns with a relevant outcome. In case this is not clear, let me give you a detailed example. I'd like to give you the example of a depression questionnaire. Here is the scenario for you. Suppose you're developing a new depression screening tool, which is designed to identify individuals who are experiencing depression. The question here is, how do you assess the criteria validity in this case? There are 6 steps which you can use to establish criteria validity. The first is develop the tool. How do you develop a tool? You have to create a new questionnaire or assessment method intended to detect depression symptoms. So this is the first step. You have to develop a new questionnaire or assessment method which detects depression symptoms. You may ask me, what is the second step? The second step is to select the criteria. What does it mean when I say select the criteria? Use an established, validated method for diagnosing depression, such as clinical interview by a licensed psychologist or psychiatrist. This method serves as your criteria because it is already recognized as an accurate measure of depression. At this stage, you have a new questionnaire. You also have an old questionnaire. Let's now talk about step number 3. You have to conduct the study in step number 3. That is, you administer both the new depression screening tool and the established clinical interview to a group of participants. The clinical interview provides a diagnosis of depression, yes or no. The fourth stage is very interesting. This is a stage wherein we compare the results of the new questionnaire with that of the existing questionnaire. For example, if the clinical interview diagnoses a participant as depressed and the new tool also identifies them as having depression, this is a match. Congratulations. The results of the new questionnaire matches that of established questionnaire. Number 5 is to analyze the correlation. This is a very, very important step. And this video, I'll be showing you how you can analyze the correlation. In this step, we calculate statistical measures like correlation coefficients to see how closely the results of the new tool align with the clinical diagnosis. Now, there is a possibility that you get a high correlation. A high correlation indicates that the new tool is effective at predicting the depression diagnosis. Now, how do you interpret the findings of criteria validity? A high criteria validity is obtained if the new tool accurately predicts the clinical diagnosis most of the time. It has strong criteria validity. This means it is a reliable tool for identifying depression. On the other hand, what about low criteria validity? If the new tool fails to predict the clinical diagnosis accurately, it may need improvement. One question which people ask me is, why do we need criteria validity? Why it matters? High criteria validity means that the new tool that you have developed is a good predictor of the established outcome. In this case, the clinical depression. It ensures that your new tool is useful and effective in real-world settings where accurate detection of depression is critical. In summary, criteria validity helps you assess whether your new tool or test accurately predicts or correlates with an established measure or outcome, thereby demonstrating its effectiveness and reliability. In short, if you want to use criteria validity, remember the golden rule here. You have to use either Pearson's correlation or Spearman's rank correlation, depending on the type of variable that you have. Typically, criteria validity should be used when you have a new questionnaire. With this background, let me now proceed to show you how to establish criteria validity using two different methods. First, let me show you the questionnaire that I will be using. As you can see here, this is a Word document. In this Word document, I'm telling you how do you check for the validity criteria on a 5-point Likert scale questionnaire. You can see here, 1 here stands for strongly agree, 2 stands for agree, 3 for neutral, 4 for disagree, and 5 stands for strongly disagree. In this questionnaire, we are trying to assess the response of the participants on the way of entertainment preference. How do you derive your entertainment? Do you derive your entertainment by watching cinema, or do you prefer to go out? Are you a very social kind of a person? Do you like sports? Do you like any other activity which is part of your hobby, like music, so on and so forth? We have a scale of 21 questions. Take a look at the first column. This is what we are calling as variables. Under the variable section, we have 21 attitudes, attitude 1, 2, 3, so on and so forth. Next, we have individual item statements. The first attitude represents, I enjoy going to the cinema. The second attitude represents I like a wide range of choice in the video shop. The third attitude represents my leisure activities are mainly out of home. The fourth represents I would rather watch TV than go out for a video. So these are some of the items that we have. As I mentioned earlier, this is an ordinal scale variable. It is a Likert scale questionnaire. So there are 5 possible responses: strongly agree, neutral, disagree, and strongly disagree. This questionnaire has been administered to different participants, and we have recorded the results in SPSS. So in the next stage, I will be showing you the data set, and using the data set, how we can establish criteria validity on this data set. To do this, let me proceed to show you SPSS. This is my data set. You can see here, I've got ID, which indicates the respondent ID, and there are 21 questions starting with attitude 1. Sorry, this is attitude 1. This column represents attitude 2. Then I have attitude 3, so on and so forth. Like this, I've got 21 questions. What is the sample size of this data set? You can see here, I've got a sample of 100. This is very, very important. Now, the first method of checking criteria validity, I repeat, I will be now showing you how to check the criteria validity. To check the criteria validity, you have to do a data preparation step. Please observe, I've got no column after attitude 21. I do not have the consolidated score for these 21 items. So the first step that you need to do is you need to create a consolidated score against each and every individual. How do you do this? To create a new column, what you can do is you can click on the transform menu bar that you are seeing at the top. The very first option here is compute variable. Let me click on the option compute variable. SPSS is asking you to specify the target variable name, which I will be calling as total. This is the total score. Next, under the numeric expression, you have to add up each of these 21 columns. How do you do this? Under the function group section, please click on all. Let me scroll down. In fact, I can also choose the option arithmetic. We need a function which is called as the sum function. I might as well type the sum function here because I'm going to total up these 21 columns. Sum of as you can see here, I have typed all the 21 variable names. So what the sum function will do is to create a new column which will add up the scores for each and every individual. You have each of these 21 columns inside the sum function. Once you have typed the sum function, you can go ahead and hit the OK button. This is the output window. Let me go back to SPSS. This is the data view. You can see here a new column called as total is created, which is basically aggregating the score of each of these 21 attributes. So the first person's total score is 58. Second person's score is 60, 58, 62, so on and so forth. After you've created the total score, the second step is to go to the correlation option. Let me now go to analyze. Here you have the option called as correlate. SPSS displays 3 separate options for correlate. You have to click on the very first option, bivariate. As you can see here, under the bivariate correlation, let me click on reset. We have 21 original attributes and total at the end. This is the trick. For easier interpretation and visibility, first you need to select total. Lot of people select items. It gets very confusing. Please include total column right at the beginning. Then all the other variables can be moved into the variable selection. Make sure that you have selected the option for Pearson's correlation. So here we are checking the correlation of each of these items on the new column, namely total. Once you have made the selections, you can go ahead and hit the OK button. Since I have already generated the correlation matrix, let me just cancel this and show you the output of the correlation matrix. As you can see here, this is the correlation table that SPSS generates. Along the row, you have 22 variables. The first one is the total. And after that, you have attitude 1, 2, 3, so on and so forth. Along the column as well, you have 22 columns. That is total, attitude 1, 2, 3, 4, so on and so forth. The diagonal elements here are all 1 because we are checking the correlation of a particular variable on itself. So you can see here along the diagonal from the top left to the bottom corner, you'll have a value of 1, implying that a correlation value of a variable with itself is 1. We need to ignore it. Again, the values at the top, that is above the diagonal and below the diagonal, will always be the same. Please have a look at this 0.309 and 0.309. Here we have 0.691. Here we have 0.691. Then you have 200 and, my apologies, 0.200 and 0.200, which means the upper triangle and the lower triangle will match. And therefore, you can ignore the upper triangle and focus on the lower triangle. Let me now focus on only one column. You can see here, this is the column that we need to focus on. There are 3 values: Pearson's correlation, significance value, and n. In the first method, we will be just checking the significance value. I repeat, just check the significance value. What should you observe? You need a significance value of less than 0.05. If you are getting a significance value of less than 0.05, congratulations to you. It means that the particular item is satisfying validity criteria. On the other hand, if the significance value is greater than 0.05, that particular item is a misfit. It violates the validity criteria. So this is the thumb rule: less than 0.05 significant, and therefore it's a good sign. Greater than 0.05, it is a problem for us. Have a look at the first 9 variable. Let's look at the significance value 0.002, less than 0.05. Fantastic. Attitude 2, the significance value is 0.000, again less than 0.05, so it's a good news. Attitude 3, the significance value is 0.046, less than 0.05. It's a good sign. The same trend continues when I check the correlation for the first 9 values, right? It is the significance value is less than 0.05. Here's where the problem, and I'd like to draw your attention to this point. Attitude 10 has a significance value of 0.860. Let me repeat this for you. Significance value of attitude 10 is 0.860, which is bigger than 0.05, and hence it is insignificant. What does that imply? Attitude 10 is violating the validity criteria. Therefore, attitude 10 should be removed because it does not satisfy the criteria validity. The same story applies to attitude number 5, because here again the significance value is 0.534, which is bigger than 0.05. The moment you see the significance value bigger than 0.05, it means that that item is violating the validation criteria. Next, attitude number 7, again 0.764. 0.764 is greater than 0.05, implying that the validity criteria is violated. Attitude 1, 0.000, we are safe. Attitude 12 and 13, again you see the significance value is high. It is greater than 0.05, and therefore we need to be careful about these items. They're clearly violating the validation criteria. Let me scroll down. The rest of the items look fine. Let me draw your attention to attitude number 21.139, which is again a problem area because it is greater than 0.05. So this is how you can go ahead, generate the correlation matrix and check the significance value of the Pearson's correlation to check whether certain items meet the validation criteria or violate the criteria. Let me quickly recap this method for you. If the significance value is less than 0.05, thumbs up. If the significance value is bigger than 0.05, thumbs down, which means we have a problem. So clearly, attitude number 10, attitude number 5, attitude number 7, attitude number 12, attitude number 13, and finally, when you look at attitude number 21, all of them are invalid items. They are violating the criteria that we have specified. Now, this is as far as method 1 is concerned. What is the second method? So here's where it gets interesting and slightly tricky. So I would request you to pay attention to method number 2. Before showing you method number 2, let me show you the Excel sheet. This is the original Excel sheet. I'd like to explain how to calculate validity of the questionnaire in method 2. There are some important points that you need to pay attention to. First is verify the sample size in the data. Second one is to obtain the degrees of freedom, which is n minus 2. You need to remember this. It is simply n minus 2 for Pearson's correlation. Now you may ask me, sir, tell me the test criteria. What you need to do is you need to compare the calculated value of the correlation coefficient, which you have obtained from SPSS, against the critical value of 0.05 level of significance and obtain from the table value. Let me just break this down. SPSS has given you the correlation coefficient, which is called as calculated value, because this is obtained after applying the formula for Pearson's correlation. You need to compare the results of calculated value with that of the critical value obtained from the table. Now, if the calculated value is greater than the table value, it is significant, and hence the question that we are talking about is a valid question. I'll repeat this for you. If the calculated value is greater than the table value, it is significant, and hence the question is a valid question. Let me take you through one example. The same procedure can be applied for the rest of the questions. If you are considering question number 1, n is 100. The degrees of freedom in this case would be 100 minus 2, which is 98. We have to check the critical value at 98 degrees of freedom and 5% in the table. This can be difficult for those people who are very new, and therefore let me go ahead and show you how to check the critical value. What you're seeing now is the critical values for Pearson's correlation coefficient. I repeat, this is nothing but critical values for Pearson's correlation coefficient. There are two parameters here. One is the degrees of freedom along the row. Remember, the degrees of freedom that we have to look at is 98. The second would be the significance level. For one tail test you have, I will be performing a two tail test, 0.50, 0.20, 0.10, and 0.05. I'm interested in looking at a 5% level of significance. In other words, 95% confidence level. I repeat, 95% confidence level. This is the fourth column from the top. The first column is 50%, then 20%, then you have 10%. We have to look at 50%, my apologies, 5% significance level. Let me scroll down now. You can see here, when the degrees of freedom is 98 and the significance level is 5%, the table value or the critical value that we are obtaining is 0.1966. This is very, very important. It is 0.1966. Let me now go back to Excel, and here you can see the critical value at 98, the critical value for 98 degrees of freedom and 5% significance level is 0.1966. What we need to do at this stage is we need to check all the items of the questionnaire one by one. Let me interpret the results for the first question. Have a look at the calculated value, which is 0.309. You may be wondering, where did I get 0.309? Here's where I'll be going to SPSS. You can see here 0.309 is the calculated value for Pearson's correlation. 0.309. Earlier I had looked at significance level. Currently I'm looking at attitude 1. You have to do the same thing for each and every attitude. For the next question, it is 0.691 and 0.200, so on and so forth. Now we can focus on 0.309. This is the calculated value. You can see here, we are comparing the calculated value of 0.309 against a critical value of 0.1966. Now, what do we obtain here? There is a small mistake. Let me rectify this particular mistake. You can see here the value of 0.309 is clearly greater. It is greater than the critical value of 0.19. This is the correction that I have made. 0.309 is bigger than 0.19. So since it is bigger than 0.19, therefore we can say that it is significant. So it is a valid question. So this is how you need to look at method number 2, that is obtain the calculated value from SPSS, generate the table value. You will compare the calculated value with the table value. If the calculated value is bigger than the table value, it is significant and therefore a valid question. If the calculated value is less than the table value, it means that the question that we are talking about is invalid. I have shown this example for one question. Let me now proceed to show you the results of all the 21 items. You can see here, there are 5 columns here. In the first column, I am tabulating all the questions. The second column, very interestingly, you have the Pearson's correlation value. This is the calculated value which I've obtained from SPSS. You can see here 0.309, 0.691, 0.2. All these are values which I have obtained from SPSS. Now, the next column that you have to focus on is column number D. Please have a look at this. This is the critical value of Pearson's R. How have I obtained this value? I have obtained this value by looking at the table. I've shown you how to look at the table. For degrees of freedom 98 and level of significance 5%, the table value is 0.1966. What you need to do in the next step is compare calculated value with that of the table value. So you will have to check if column number C is bigger than column number D. If it is greater, there is one message. If it is lesser, it is a completely different story that we will be telling. When you look at the first question, 0.309 and 0.1966, the criteria is if the calculated value is bigger than the critical value, go ahead and reject. Therefore, column E, I'm saying is reject null hypothesis, in which case the conclusion will be criteria validity is established for attitude 1. So for the first set of questions, almost all of them are basically getting selected. However, when you look at the next set of questions, have a look at the calculated value. Please compare it with the table value. You have to accept the null hypothesis here and conclude that the criteria validity fails for attitude number 4, 5, 7, 10, 12, 13, 14, and 21. These are the questions which fail to meet the criteria validity. With this, I have come to the end of today's video. In today's video, we have seen a detailed presentation of two separate methods as to how we can conduct criteria validity. The first one is using Pearson's correlation significance value. Look at the significance value, compare it with 0.05. If it is lesser, you reject the null hypothesis. If it is greater, you accept. That is the first method. In the second method, what we have done is to obtain the calculated value, and we have compared the calculated value with that of the table value. If the calculated is greater, you reject, else you do not reject. I hope you have liked this video. I request you to subscribe to my channel. Also like and share my videos. Thank you very much for watching this video. Have a great day ahead.